What we're going to talk about in Chapter 6 is centroids. Now, the beginning of this does talk about another topic called center of gravity. And the difference between center of gravity and centroids is really a difference of how many dimensions you're dealing with. When I talk about center of gravity, okay, which we really don't deal with a whole lot, when we talk about center of gravity, we're talking about the center of gravity of a three-dimensional object. Okay? So an object that has volume, and we're looking at the center of gravity of that three-dimensional object. What we'll talk about in here exclusively is going to be a centroid. A centroid is the center of gravity, but you're not dealing with a three-dimensional object, you're dealing with a two-dimensional plane or two-dimensional area. So since we deal with like whiteboards and we deal with textbooks and we deal with pieces of paper and things that we draw on them, we're typically looking at a two-dimensional surface. So we'll stick with centroids, but when you get out there, you know, in the real world, of course, we deal with three-dimensional objects. So what is, you know, the center of gravity? Well, I like to think of the center of gravity as being like the balancing point that's inside a three-dimensional object. Okay? So if I had a book, the book's a three-dimensional object here. If you could find, and a book has all these molecules and little forces, incremental forces of weight that act down towards the center of the earth. If you could find the point in that book, you know, where all the weight molecules on this side of the book perfectly balance the weight molecules pulling down towards the center of the earth on that side, as well as on this axis, this side, and this side, you can find that balancing point in there. That would be the center of gravity. Okay? Now what the center of gravity would also tell us is that's where the resultant weight would be acting. So why is this book bouncing on my fingertips? Well, one, I'm cheating because I don't do this with one finger. Okay, but why is it in balance right now? Well, because how much, this book weighs 3 pounds, let's say. That 3-pound force is acting down towards the center of the earth, right? Well, it happens to be acting down right where my fingers are supporting it. You know? If I tried to support this over here, what would happen? The book would fall, right? So, you know, if I could find that point, and really that point exists inside the book, okay, but if I can find that book in the point in 3 dimensions, that's the center of gravity. In 2 dimensions, which is what we deal with, that point is called the centroid. Okay? So again, you might be confused with some of the language that we use, centroid, center of gravity. They're both related to each other, but one's a 3-dimensional aspect, center of gravity. The other one's a 2-dimensional aspect, centroid. Okay? So we'll deal primarily with centroids. Why are centroids important for us? Well, as I told you about here with the book, a lot of times we like to take a shape and we like to know where the centroid lies. Because if that shape dealt with like loads, it's very important for us to know where the resultant force of the loads is going to act. Okay? It's also important because coming up here in a couple chapters, what we'll deal with is we'll deal with shapes for like beams. And the beam will have a certain cross-section. Maybe it'll be a rectangular cross-section. We would like to know where the centroid of that cross-section is because the beam, when we talk about bending, will bend about the centroidal axis. And again, right now, that doesn't mean much to you. But again, when we come up here in a couple weeks, we start talking about bending. Okay? A lot of our shapes end up bending about the centroidal axis. Okay? So where that centroid is located is an important part of the cross-section of a particular shape. All right? So that's why it's going to be important for us. What really is a centroid? Okay? Or what are the skills that you need to know in this particular topic? Here's what you need to know. You need to be able to find the centroid. What is the centroid? Well, the centroid's a location. Okay? It's a location within a given shape. So if my shape is this rectangle, I might want to know what where the centroid is, because it's a location. So I could have any shape, and what I'd like to know is where the centroid of that shape's located. How are we going to do that? Well, the centroid of any shape is going to be defined by two orthogonal axes. It's going to be defined by an x-axis. We're going to call that the centroidal x-axis. And a y-axis, and we're going to call that the centroidal y-axis. So when I locate a centroid, a point, really what I'm doing by locating that point is I am locating as well, or establishing as well, the two axes that intersect to make up that point, to find that point, to locate that point. All right? This is not too much different than you giving somebody directions. Okay? I mean, if we would look at a map, a lot of our maps are based on grids, right? In fact, a lot of our cities and our streets are also based on grids. So if you're downtown and you're up on 8th Street, and somebody says, how do I get to 5th Street? What are you going to tell them? Go down, and how many blocks would you tell them to go down? 3 blocks. If you're up on 8th Street, I mean, if it was a regular city, you'd say, hey, I'm up on 8th Street, go down south 3 blocks, and you'll get to 5th Street. Okay? So, you know, and a lot of cities have north-south streets too. I mean, they're usually not the numbered streets, but it's like, hey, Vine Street, so Main Street, right, you know, so, hey, go a couple blocks east or, you know, 3 blocks west and you'll get to this street. So a lot of our maps and whatnot are sort of, and cities are laid out on sort of a grid type system as well. So, if somebody asks you, hey, how do I get to 5th Street, and what would be the first question you'd ask them if they didn't tell you this in their problem statement? What street are you on? So you need to know where your starting location is, okay? To give somebody directions, you need to give somebody a starting point. That's the same way with centroids. We've got to have an origin or a place of beginning. All right? From that origin, I'm going to travel so far in the x direction to get to the y centroidal axis. I'm going to call that distance, x distance, that I travel to get to the y centroidal axis. I'm going to call that my x bar. There's a bar across the top. I'm going to call it my x bar distance. From my origin, the y distance that I need to travel to get to the x centroidal axis is what I'm going to call the y bar distance. So, if dimensional shape, if I'm given an area, okay, and I give you a point of origin, and somebody tells you what the x bar distance is from that origin to the centroid of that shape, the centroidal y-axis, and they give you the y bar distance, you're going to be able to locate that centroid. That's what you have to do in Chapter 6. That's all that you need to do in Chapter 6. Is you have to come up with the x bar and the y bar distances.